For as long as humanity has gazed at the stars, we've wondered, are we alone? It's a question as old as civilization itself, woven into ancient myths and modern science fiction. From stories of celestial gods to Hollywood blockbusters like Contact and Arrival, this question has fascinated us across centuries, cultures, and continents. Yet, it's more than just curiosity. It's existential. What if someone else is out there, watching the same stars we are? And yet, for all our wondering, there's a haunting silence. Despite billions of galaxies, trillions of stars, and countless planets, the universe feels eerily quiet. Why haven't we heard from anyone? This is the crux of the Fermi paradox. Physicist Enrico Fermi famously asked, "Where is everybody?" If intelligent life is common, shouldn't we see some sign, radio signals, spacecraft, or even alien artifacts? If the universe is so vast, why hasn't anyone picked up the phone? Could it be that advanced civilizations destroy themselves before they make contact? Or are we just listening on the wrong frequency? Our quest to answer this question started humbly. Ancient stargazers used only their eyes to map the heavens and dream of other worlds. Then came Galileo's telescope, opening our eyes to the vastness of space. The real turning point, however, came in the mid-20th century, with the invention of the radio telescope. For the first time, we had the tools to eavesdrop on the universe, listening for whispers from other intelligent beings. This breakthrough transformed the search for extraterrestrial intelligence, or SETI, from a fantastical idea into a serious, scientific endeavor. Radio telescopes like the famous Arecibo Observatory allowed us to both send and receive signals across the cosmic void. For decades, scientists have tuned in, hoping to hear that one unmistakable signal, a cosmic hello. So far, the universe has answered with silence. But does that mean no one's out there? Or are we simply not looking hard enough? Our search has only just begun. The search for extraterrestrial intelligence, or SETI, is humanity's grand attempt to answer one of our most profound questions. Are we alone in the universe? At its core, SETI is about listening, scanning the heavens for faint whispers of intelligent life amidst the overwhelming roar of cosmic noise. But how do you find a needle in a haystack the size of the universe? SETI's origins date back to 1960, when astronomer Frank Drake pointed a radio telescope at two nearby stars, Tau Ceti and Epsilon Eridani, in a project called Project Ozma. Armed with a simple receiver, Drake searched for narrowband radio signals, distinct markers of technology that nature doesn't typically produce. Though the search came up empty, it set the stage for decades of innovation and effort. Today, SETI is a global collaboration, driven by scientists, engineers, and dreamers who believe the silence of the stars might one day break. Modern SETI efforts rely on advanced technologies, like the Allen Telescope Array in California. This powerful array of 42 dish antennas can simultaneously scan vast swathes of the sky, sifting through billions of radio frequencies in search of anomalies. It's not just about listening, it's about filtering. The universe is full of signals, pulsars ticking like cosmic clocks, quasars roaring with energy, and countless human-made transmissions from satellites and airplanes. SETI's challenge is to separate these signals from what could be an intentional, interstellar hello. One of the most intriguing targets for SETI scientists is the water hole range of frequencies, between 410 and 1666 MHz. This range corresponds to the natural emission frequencies of hydrogen and hydroxyl, the two components of water, a molecule essential for life as we know it. Scientists speculate that intelligent civilizations might choose this range to send signals, believing it to be a universal common ground. But here's the mind-bending part. What if we've already heard the signal but didn't recognize it? Buried in the endless static we collect, could there be a message, a greeting, a warning, or even a plea for help that's waiting to be decoded? Every second, SETI archives terabytes of data, much of it still unanalyzed. As our technologies improve, we're constantly revisiting this data, hoping that with fresh eyes and better tools, we might uncover something extraordinary. The science of SETI is as much about patience as it is about innovation. Every new discovery in physics, computer science, or astronomy brings us closer to refining our search. Could the breakthrough be just around the corner? Or have we already missed it? The stars remain silent, for now. In the summer of 1977, something extraordinary happened. At the Big Ear Radio Telescope in Ohio, astronomer Jerry Eman was scanning the skies for unusual radio signals. Amid the endless stream of mundane data, he spotted something that made him grab a pen and circle it. Next to the numbers, he scribbled one word: "Wow!" That brief, 72-second signal, now famously known as the WOW signal, was unlike anything scientists had ever detected. It came from the direction of the Sagittarius constellation, close to the Waterhole Range. The frequency band SETI considers ideal for interstellar communication. So what made the WOW signal so remarkable? For one, it was highly concentrated, narrowband, and powerful. The kind of signal no known natural phenomenon could produce. And yet, despite decades of searching the same region of space, we've never heard anything like it again. This fleeting blip of data remains one of the greatest mysteries in the search for extraterrestrial intelligence. Was it a message from an alien civilization, a cosmic fluke, or perhaps even a mistake? The frustrating truth is, we may never know. The WOW signal is just one of many tantalizing puzzles in the cosmos. In recent years, astronomers have been captivated by fast radio bursts, FRBs, intense flashes of radio waves originating from distant galaxies. Some of these bursts occur only once, while others seem to repeat, leading to wild speculation about their origin. Could they be the result of extreme astrophysical phenomena, like neutron stars colliding? Or could they, just maybe, be intentional signals? One of the most intriguing cases is FRB 121112, a burst that has been detected multiple times from the same location. It's like hearing a knock on your door, not just once, but repeatedly. While the prevailing theory is that these bursts are caused by magnetars, highly magnetized neutron stars, scientists haven't completely ruled out the possibility of something more deliberate. But here's where things get tricky. To confirm that a signal is truly extraterrestrial, scientists must rule out every possible source of interference. Human-made signals, from satellites, airplanes, and even microwaves, have a nasty habit of mimicking the kind of patterns we're looking for. The infamous case of the Periton signals, once thought to be mysterious bursts from deep space, turned out to be caused by staff members opening microwave ovens at a nearby observatory. Still, the WOW signal and other cosmic mysteries keep scientists and dreamers alike captivated. They remind us of the immense possibilities and the sheer unpredictability of the universe. And yet, they also carry a haunting question. What if that brief blip was our only chance to connect? What if we missed our one opportunity to say hello to the cosmos? The answers remain elusive, but the search continues. Somewhere out there, another WOW moment may be waiting, Are we ready to hear it? Reaching out to alien civilizations sounds simple in theory. Send a signal and wait for a reply. But in practice, it's an almost impossible challenge, like tossing a message in a bottle into a vast, turbulent ocean. The first obstacle? Distance. Space is unimaginably vast, even at the speed of light, 186,000 miles per second. A signal sent to the nearest star system, Alpha Centauri, would take over 4 years to arrive. And that's just next door, cosmically speaking. For civilizations farther away, responses could take centuries, even millennia. By the time a reply reaches us, the senders might no longer exist, or we might not. Adding to the difficulty is the unknown factor of alien technology. Our search methods rely heavily on technologies we understand, like radio waves and laser pulses. But what if an advanced civilization communicates using something entirely different? Methods beyond our comprehension, like quantum signals or neutrino beams. To them, we might seem like ants, waving flags at passing airplanes, completely unaware of the sky above. This brings us to a sobering idea known as the Great Filter Hypothesis. It suggests that certain barriers in the evolution of life might be nearly impossible to overcome. Perhaps microbial life is common, but intelligent civilizations rarely arise, or maybe advanced societies inevitably destroy themselves before achieving interstellar communication. Nuclear war, environmental collapse, or runaway artificial intelligence could all act as this filter, wiping out civilizations before they ever make contact. And here's an even more chilling thought. What if alien civilizations existed but have already gone extinct? We could be looking at a silent cosmos, not because life isn't out there, but because it's already come and gone. Brief flashes of brilliance snuffed out by the same forces that might one day threaten us. These challenges are daunting, but they're also part of what makes the search so compelling. Every obstacle we face underscores just how extraordinary it would be to succeed. And as we continue to push the boundaries of technology and imagination, we can't help but wonder, is the silence of the stars a sign that no one's out there? Or that we just haven't figured out how to listen yet? Reaching out to alien civilizations isn't just a scientific challenge. It's a profound ethical dilemma. Should we make our presence known to the cosmos, or is it safer to remain silent? For decades, scientists and philosophers have debated this question, and the stakes couldn't be higher. After all, once we send a message into the void, there's no taking it back. At the heart of this debate is METI, or Messaging Extraterrestrial Intelligence, a branch of SETI focused on actively sending signals to potential alien civilizations. Supporters argue that we've already made our presence known through decades of leaked radio and television broadcasts, so why not be intentional about it? METI advocates believe reaching out could lead to incredible opportunities for cultural and scientific exchange. An interstellar handshake that could redefine humanity's place in the universe. But not everyone agrees. Critics warn that announcing ourselves could invite danger. Stephen Hawking, one of the greatest minds of our time, issued a chilling warning. Be careful what you wish for. He compared potential alien encounters to the arrival of Europeans in the Americas, a meeting that didn't end well for the indigenous populations. What if alien civilizations are hostile, viewing us as a resource to exploit or a threat to eliminate? Even indifference could be catastrophic. An advanced species might see us the way we see ants, beneath notice, yet easily swept aside. And then there's the question of preparedness. Are we, as a species, ready for the consequences of making contact? Imagine the cultural and psychological shock of receiving a reply to one of our messages. Would it unite humanity in awe and cooperation? Or would it deepen our divisions, fueling fear and mistrust? Even the act of crafting a message raises ethical questions. Who gets to decide what we say, and on whose behalf? Do we represent Earth's diverse cultures, or just the most powerful voices among us? The risks of reaching out are undeniable, but so are the rewards. A successful contact could unlock unimaginable knowledge, from advanced technologies to insights about the nature of life and the universe. But with so much uncertainty, some argue the wiser course is to listen in silence. After all, once the message is sent, the consequences, good or bad, are beyond our control. So we're left with a haunting question. Are we ready for the consequences of contacting alien life? It's not just a question of science, it's a question of survival, of morality, and of what it means to be human in a universe we've only just begun to understand. Humanity has always been compelled to leave a mark, to tell our story to anyone, or anything that might be listening. And in our quest to connect with the cosmos, we've sent more than just random signals. We've crafted deliberate, thoughtful messages, our own messages in a bottle, drifting through the vast, uncharted ocean of space. But what do these cosmic postcards say about us? One of the most famous examples is the Voyager Golden Records, launched aboard the Voyager spacecraft in 1977. These phonograph records, attached to Voyager 1 and 2, were designed to tell the story of Earth to any extraterrestrial beings who might stumble across them. Curated by a team led by Carl Sagan, the records contain an eclectic mix of information. Greetings in 55 languages, sounds of Earth like a baby's cry and a thunderstorm, 90 minutes of music ranging from Bach to traditional folk songs, and even encoded images of human anatomy, landscapes, and scientific achievements. It's a snapshot of who we are, or at least who we aspired to be in the 1970s. But the Golden Records were just the beginning. In 1974, astronomers sent the Arecibo message, a binary-coded radio signal aimed at a star cluster 25,000 light-years away. It contained basic information about humanity: numbers, chemical formulas, a depiction of the solar system, and even a crude image of a human figure. More recently, digital broadcasts like the Lone Signal Project have invited people to compose personal messages and beam them toward nearby stars, adding a new layer of intimacy to our cosmic outreach. These efforts are profoundly hopeful, reflecting our desire to be seen and understood. But they also raise interesting questions. What do these messages say about us as a species? The Voyager records showcase the beauty and diversity of Earth, but they leave out our flaws: wars, inequalities, and environmental destruction. Are we painting a fair picture, or one that flatters us? And more importantly, are we certain we want to be found? Many scientists argue that we should focus on listening before speaking. The universe is vast and mysterious, and reaching out blindly could be risky. Yet for some, the act of sending these messages isn't just about contacting aliens, it's about expressing what we value. Each project reflects our curiosity, creativity, and the belief that communication is possible, even across unimaginable distances. Still, the question lingers. What would aliens think if they judged humanity by our cosmic postcards? Would they see us as a species full of potential, or as naive children reaching out to forces we can't comprehend? Whatever the answer, these messages stand as a testament to our shared humanity. A bold declaration that, in this small corner of the cosmos, we exist, we dream, and we hope to connect. The search for extraterrestrial intelligence has entered a bold new chapter, driven by groundbreaking initiatives and cutting-edge technology. At the forefront is the Breakthrough Listen project, a $100 million endeavor funded by billionaire Yuri Milner, with the late Stephen Hawking as one of its key supporters. Announced in 2015, Breakthrough Listen is the most ambitious and comprehensive search for alien signals to date, harnessing the power of some of the world's most advanced telescopes to scan the skies for signs of intelligent life. Unlike earlier efforts, Breakthrough Listen has access to immense computing power, enabling scientists to analyze data on an unprecedented scale. Using facilities like the Green Bank Telescope in West Virginia and the Parkes Observatory in Australia, the project can simultaneously monitor billions of radio frequencies across vast regions of the sky. But the real game changer? Artificial intelligence.ai and machine learning algorithms are transforming SETI by sifting through mountains of data at speeds no human could match. These tools are designed to detect patterns, subtle anomalies in the cosmic static that might otherwise go unnoticed. In fact, AI has already proven its value, uncovering previously missed signals in archived data. As this technology evolves, our ability to identify genuine extraterrestrial signals amidst the noise of pulsars, quasars, and human interference will only improve. The future of SETI doesn't stop at Earth-based telescopes. New projects envision space-based observatories that would bypass the limitations of our atmosphere, offering clearer and more expansive views of the cosmos. Another promising frontier is laser communication, which could detect highly focused light pulses from distant civilizations. These advancements open doors to possibilities we could only dream of just a few decades ago. And here's the question that captures our imagination. Could the first contact happen in our lifetime? With the speed of innovation accelerating and new resources pouring into the search, the idea no longer feels like science fiction. Some scientists believe that if intelligent life exists within a few hundred light years of Earth, our current or upcoming technologies might detect it. Yet, the search remains a race against time and uncertainty. Are we looking in the right places? Are we using the right tools? And will we recognize the signal when it comes? What's clear is that projects like Breakthrough Listen are pushing the boundaries of what's possible, bringing us closer than ever to answering humanity's oldest and most profound question. Are we alone? As we scan the skies with greater precision and ambition, the universe's silence feels less daunting and more like an invitation. Somewhere out there, perhaps even now, a signal could be traveling toward us, waiting to be heard. The search for alien life is about so much more than finding others. It's about understanding ourselves. Every question we ask about the cosmos reflects a deeper question about humanity. What does it mean to be intelligent? To be alive? To reach out into the unknown? Hoping for connection? These are the questions that define us, that fuel our curiosity, and that drive us to explore the final frontier. In many ways, the journey itself may be as important as the destination. Whether or not we ever make contact with another civilization, the search forces us to push the boundaries of what we know and what we can achieve. It's a challenge that unites us, reminding us that in the vastness of space, we're all travelers on the same fragile planet, sharing the same sky.